Welcome to Business Analytics, Chapter 5, Probability and Probability Distributions. Introduction. A key aspect of solving real business problems is dealing with appropriately with uncertainty. This involves recognizing explicitly that uncertainty exists and using quantitative methods to model uncertainty. In many situations, the uncertain quantity is a numeric quantity. In the language of probability, it is called a random variable. A probability distribution lists all of these possible values of the random variable and their corresponding probabilities. Introduction. Access probability distribution chart. The two fundamental approaches, simulation, use of decision trees. These are some of the different methods that we can look at to help decide what the probability of an outcome is. Uncertainty and risks are sometimes used interchangeable, but they are not the same. You typically have no control over uncertainty. It is something that simply exists. In contrast, risk depends on your position. Even if something is uncertain, there is no risk if it makes no difference to you. Probability essentials. Probability is a number between 1 and 0, 0 and 1, that measures the likelihood that some event will occur. The event of a probability with 0 cannot occur, whereas the probability of an event is certain to occur. An event with the probability greater than 0 and less than 1 involves uncertainty. And the closer its probability to 1, the more likely it will occur. Probabilities are sometimes expressed as percentages or odds, but these can be easily converted to probabilities 0 to 1 scale. The rule of complements. The simplest probability rule involves the complement of an event. If A is an event, then the complement of A denotes A bar. A bar, or in some books, AC, is the event does not occur. If the probability of A is P times A, then the probability of its complement is P A bar equals 1 minus PA. Addition rule. Events are mutually exclusive if at most one of them can occur. That is, if one of them occurs, then none of the others can occur. Exhaustive event means that all exhausts have all possibilities, and all events must occur. The addition rule of probability is the probability that at least one event will occur. When the events are mutually exclusive, the probability that at least one of the events will occur is the sum of their individual probabilities. Conditional probability and multiplication rule. A formal way to revise probability on the basis of new information is to use conditional probabilities. Let A and B be any event with the probabilities A times B, P times A, and P times B. If you're told that B has occurred, then the probability of A might change. The new probability of A is called the conditional probability of a given B, A given B, or A or B times A or B. It can be calculated with the following formula. Conditional probability and multiplication rule. The numerator is the probability that A and B occur. This probability must be known as find B, A, B. However, in some applications, P times A or B and P times B are known. Then you can multiply both sides of the equation by P plus and obtain the multiplication rule for B and probability of A and B. Assessing uncertainty at a Bender company. Objective: to apply probability rules to calculate the probability that Bender will meet its end of July deadlines, given the information it has at the beginning of July. Solution: let A be the event that the Bender meets its end of July deadlines, and let B be the event that the vendor receives the material it needs from the supplier by mid-July. Vendor estimates the chances of getting the material on time are 2 out of 3, so that P times B is 2 divided by 3. Vendor estimates that if it receives the required material on time, the chances of meeting the deadline are 3 out of 4, so that it is probability of A or B equals 3/4. The uncertainty is depicted in the graphic from the probability tree. So we start out at the beginning. The first point is probability of B, which is 2/3, and the bottom would be 1/3. So if we look here, this would be 3/3 or a whole. As we move up, probability of completing everything is 3/4, 1/4, 1/5, and 4/5, respectively, as we take the probability chain down this. This addition rule is a mutually exclusive event that applies. There are situations where the probabilities P times A or B, and P times A or B bar are equal. In this case, A and B are probabilistic independent variables. This does not mean that they are mutually exclusive. Rather, it means that the knowledge of one event is of no value when assessing the probability of the other. When two events are probabilistic independent, and multiplication rules simplify. To tell whether events are probabilistic independent, you typically need empirical data. Equally likely events. In many situations, outcomes are equally likely, flipping coins, throwing dice. Many probability, particularly in games of chance, can be calculated by using an equally likely argument. However, many other probabilities, especially those in business situations, cannot be calculated by equally likely arguments simply because the possibility outcomes are not equally likely. Subjective versus objective probabilities. Objective probabilities are those that can be estimated for long-run proportions. The relative frequency of an event is the proportion of time the event occurs and the number of times the random experiment is run. A famous result called the law of large number states that relative frequency in the long run will get closer and closer to true probability of an event. However, many business situations cannot be repeated under identical conditions, so you must use subjective probabilities in this case. A subjective probability is the one person's assessment of the likelihood that a certain event will occur. Probability distribution of a random variable. A discrete random variable has a finite number of possible values. A continuous random variable has a continuum of possible values. Usually a discrete distribution results from a count, whereas a continuous distribution results from a measurement. These distinctions between count and measurement is not always clear-cut. Mathematically, there is an important difference between the discrete and continuous probability distributions. Specifically, a proper treatment of continuous distribution requires calculus. These essential probabilities of discrete, random, and variables and its associated probability distribution are quite simple. To specify the probability distribution of X, we need to specify its possible values and their probabilities. We assume that there is a k possible value denoted. The probability of a typical value is denoted. Probability distributions must satisfy two criteria. The probabilities must be non-negative. They must sum to 1. Cumulative probability is the probability that the random variable is less or equal to a particular value. Assume that 10, 20, 30, and 40 are possible values of a random variable x and corresponding probabilities. For the addition rule to be, the cumulative must be probability x is less than or equal to 30 can be calculated as 10, 20, 30 equals 0.75. Summary of the measures of probability distribution. The mean is often denoted as U, is a weighted sum of the possible values weighted by the probability. It is also called the expected value of x and denoted as E times x. To measure the variability in the distribution, we calculate the variance of the standard deviation. The variance is denoted by sigma squared, or var times x is a weighted sum of the squared deviations of the possible values from the mean, where the weights are, again, the probability. Variance of the probability distribution, sigma squared, is, at various computing, a more natural measure of variability is the standard deviation, denoted by sigma, or STDEV times x. It is the square root of the variance. Objective: to compute the mean, variance, and standard deviation of probability distribution. Make a return for the coming year. Solution: market returns for 5 economic scenarios. Estimate 23, 18, 15, 9, and 3. The probabilities of these outcomes are estimated to be 12, 25, and 0.08. Procedure for calculating summary measures. Calculate the mean return in B11. For the formula, use the sum product of that table. To get ready for compute the variance, calculated the square deviation from the mean by entering the formula and copying it down. Condition mean. There are many situations where the mean and the variance of the random variable depend on some external event. In this case, we can condition the outcome external event to find what's going on. Conditional mean formula, conditional mean variance formula. All calculations are done easily with Excel, and we can look at the Excel example. The normal distribution. The single most distribution in statistics is the normal distribution. It is a continuous distribution in the basis of the familiar symmetric bell curve. Any particular normal distribution is specified by its means, can be standard deviation. By changing the mean, the normal curve shifts to the right or left. By changing the standard deviation, the curve becomes more and less spread out. There are really many normal distributions rather than just a single one. The normal distribution is a 2-parameter family where the 2 parameters are mean and standard deviation. For continuous distributions, instead of a list of possible values, there's a continuum of possible values, such as value between 0 and 100, where the values are greater than 0. Instead of assigning probability to each individual in the continuum, the total probability of 1 is spread over this continuum. The key in this spreading is called density function, which acts like a histogram. The higher the value of the density function, the more likely the region of the continuum is. Density function, usually denoted by fx, specifies that the probability of distribution of continuous random variables. The higher the fx, the more likely x is. The total area between the graph and fx is the horizontal axis, which represents the total probabilities equal to 1. Fx is a non-negative for the possible values of x. Probabilities are found from density functions as the area. The normal density function, a normal distribution, is a continuous distribution with possible values ranging over the entire number line, from minus infinity to plus infinity. Only a relatively small range has much chance of occurring. The normal density function is actually quite complex, in spite of the nice bell-shaped appearance. The formula for a normal density function, where u and sigma are the mean and the standard deviation, as follows. Standardizing z-values. The standard normal distribution has a mean 0 and standard deviation 1, so it is denoted by n 0 or 1. It refers to the z distribution. To standardize a variable, subtract its mean from the divided by the 3 by the standard deviation. Standardizing allows measures of variables with different means and or standard deviations on a single scale. A z-score, z-value, is the number of standard deviations to the right or left of the mean. If the z is positive, the original value is to the right of mean. If it is negative, it is to the left. Objectives to standardize annual returns in various mutual funds. The data set includes annual returns of 30 mutual funds. Calculate the mean and standard deviation of each return and use the standard formula to calculate the z-values directly. A common use for z-values is a standard normal distribution in calculating a probability in percentiles by the traditional method. This method is based on the table of the standard normal distribution found in many statistical textbooks. The body of the table contains probabilities. The left and top margins are the possible values. Normal calculations in Excel. Two types of calculations are typically made with normal distributions, finding probability and finding percentiles. The functions used for the normal probability calculations are norm and norm S. The main difference between these is that with the S for standardized applies to only N01 calculations, where norm D applies to any normal distribution. Percentile calculations that take a probability and return a value are often called inverse calculations. The Excel functions for these are named norm invert and norm S. Again, the S is the second, indicates that it applies to standard normal. Many of the statistic functions were revamped in Excel 2010. The new functions are normal distribution, norm S distribution, norm inbin, and these words exactly like the old normal functions, except that the norm S is the same last cumulative argument, whereas case is norm dist. To calculate the probability of percentiles for standard normal and general normal distributions, solution for less than probabilities use norm dist or norm S dist directly. For greater, norm dist or norm S dist function from 1. For between probabilities, subtract the 2 and get that. For percentile calculations, use the norm IV and function. Empirical rules. 3 empirical rules apply to many data sets. About 68% of the data falls within one standard deviation, about 95 between 2, and almost all fall within for these. For these roles to hold real data, the distribution of the data must be at least approximately symmetric and bell-shaped. Weighted sums, normal at random. One of the very attractive properties of a normal distribution is that if you create a weighted sum of normally distributed random variables, the weighted sum is also normally distributed. This is true even if the random variables are not independent. If x1 through xn are independent and normally distributed random variables with common mean and common standard deviation sigma, then the sum x1 through xn is normally distributed with the n mean and variance n, and if through sigma n are any constants, then the weighted sum is normally distributed with all that. Personal training, ZTEL. To determine the test scores can be used to accept or reject job applicants at ZTEL. Scores for all applicants are approximated normally distributed with a mean of 525 and standard deviation 55. Calculate the percent of applicants who are automatically accepted or rejected given this. Find new cutoff values that reject 10% and accept 15%. quality control paper stock. To determine the machine settings that result in paper acceptable quality at paper stock. Solution. A given roll of paper must be rejected if it is actually fiber content less than 19 pounds or greater than that. The variability in the fiber content is 0.1 pound when the process is good, but increases to 0.1 when the machine calculates the probability that given a roll rejected, and so on. Analyzing investors' after-tax profit. Objective: to determine the after-tax profit, Howard Davis can 90% certain. Solution: Howard is in 33% tax bracket, so his after-tax profit is 67%. His before tax, if he invests $10,000 in certain stocks whose annual return normally distributes 5% and standard deviation of 14%, calculate the dollar amount such that Howard after-tax profit is 90% certain to be less than the amount that is calculated the 90th percentile of his after-tax. The binomial distribution is a discrete distribution that can occur in two situations. When sampling from a population, there's only two types of members, males and females, for example. When performing a sequential of identical experiments, each of has only two possible outcomes. Consider a situation when there is an independent identical trial where the probability of success on each trial is p, and the probability of a failure is 1 minus p. Define x to be a random number of successes in the n trials. Then x has a binomial distribution. Binomial in Excel, we use the bino distribution, and in 2010 bino distribution, CRIT, bino functions, old functions still work fine. Binomial, to use the binom distribute in the binom.inv. Functions in Excel calculate the binomial probabilities and percentiles in this solution. Let x be the number of successions in 100 trials of a flashlight battery, where a successful means that the battery still functions after 8 hours. Find the probability of these various events using the binomial distribution function as shown in the spreadsheet. Find the 95th percentile of the distribution of x using the binomial function. Mean and standard deviation of binomial distribution. It can be shown that the mean and the standard deviation of the binomial distribution with parameters n and p are given by the following equations. The empirical rule discusses in Chapter 2 also applies at least approximately binomial distribution. There is about a 95% that the actual number of success will be within 2 standard deviations. There is almost no chance that the number of successes will be more than 3 standard deviations. If sampling is done without replacement, each member of the population can be sampled only once. That is, once a person is sampled, his or her name is struck from the list and cannot be sampled again. If sampling is done with replacement, then it is possible that, although maybe not likely, to select a given number of the population. Most real-world sampling is performed without replacement. The binomial model applies only to sampling with replacement. However, if no more than 10% of the population is sampled, the binomial model can be used safely, even in perform. Normal approximation of the binomial. If you graph the binomial probability, you will see an interesting phenomena. The graph begins to look symmetrical and the bell is there. The normal distribution provides a very good approximation to the binomial under the conditions. One practical consequences of the normal approximation to the binomial is the empirical rule applied very well to the binomial distribution. Mutual fund really winners. To determine the probability of a mutual fund outperforming standard market indexes, at least 37 out of 52-week solution. The number of weeks where a given fund outperforms the market index is binomial distributed, with n equals 52 and p equals 0.5. This probability is quite small. Now let y be the number of at least 400 best mutual fund that beat the market at least 37 of the 52 weeks. Y is also binomial distributed with the parameters set. Daily sales at a supermarket. Objective to use the nominal and bimodal distributions to calculate the typically number of customers who spent at least $100 per day and the probability that at least 30% of all 500 daily customers spend at least $500. Historically, data indicates that the amount spent per customer is normally distributed with a mean of $85 with a standard deviation of $30. If 500 customers shop a given day, calculate the mean of the standard deviation of the numbers who spend at least $100. Then the probability that at least 30% of the 500 customers spend at least $100. This is the probability that the binomial distributed random variable with n equals 500 and p equals that. Overbooking airlines. To assess the benefits, drawbacks of airline overbooking, assume that there's a no-show rate of 10%, that is, each ticketed passenger shows up with the probability of 0.9. For a flight with 200 seats, calculate probability that more than 205 passengers show up, that more than 200 passengers show up, at least 195 seats are filled, and that the probability of 190 is. To see how sensitivity these probabilities are, the number of tickets issued create one-way data as shown below. To use binomial model to determine whether early returns reflect eventual winner of an election because of two candidates. Solution: suppose that the small percentage of votes that have been counted and Republicans is currently ahead by 540 to 460. On what basis can the network declare Republicans winner if there are 1 million voters? Use the binomial model to see how unlikely the event is. At least 540 out of the 1,000 is assuming that the Democrats will be the eventual winner. The Poisson and exponential distribution. In most statistical applications, the Poisson and exponential distribution play a much less important role than a normal and binormal distribution. However, in many applied management science models, Poisson and exponential distributions are key distributions. For example, much of the study of the problematic inventory models, queuing models, and reliability models rely heavily on these two distributions. The Poisson distribution is a discrete distribution. It usually applies to a number of events occurring within a specific period of time or space. It's possible values are more of the non-negative integers 0, 1, and 2, and so on to the upper limits. Even though there is an infinite number of possible values, this causes no real problems because the probability of significantly large values are essentially 0. The Poisson distribution is characterized by a single parameter, usually lambda, which must be positive. It is both the mean and the variance of the Poisson distribution. It is often called the rate of arrivals per hour, for example. Poisson is the same shape as the figure below. That is the first increase or decrease. Typical examples of that: a bank manager studying arrival patterns of the bank. The event of our customer arrivals, the number of arrivals in an hour distributed in lambda, represent the expected number of arrivals per hour. A retailer is interested in the number of customers who order a particular product in a week. Then the event are the customer orders for the product and the number of customers ordered in the week. Poisson distribution in lambda is expected the number of orders per week. You can use Excel to do all this using Poisson function. Either version, it's fine, so we can figure that out. Managing TV inventory at Kurland. To model the probability distribution of a monthly demand for plasma screens, TVs with a particular Poisson distribution. Solution. Because the histogram of demands for the previous months resemble a Poisson distribution, try modeling the monthly demand with a Poisson distribution. The historical average demand in the monthly is about 17, so let that lambda be 17. Now test the model. The exponential distribution, the most common probability distribution used in the model, the times between customers arrive and called the inner arrival times, is the exponential distribution. In general, continuous random variables x has an exponential distribution parameter lambda greater than 0 if the density function of x has a form. The mean of the standard deviation and the distribution are both equal and reciprocal of parameter lambda. For an exponential distribution, the probability to the left of any given value of x is greater than 0 can be calculated using the expon distribution function within Excel. The exponential density function has a shape shown below. Because this density function decreases continuous from left to right, it is most likely value is x equals 0. That was Chapter 5, Probability. Thank you.